Students, welcome to Nilagiri online video classes. In last class, we are discussed Lorentz applications. There are two applications: length contradiction and time dilation. In last class, we discussed the length contradiction. Today, we discuss about the time dilation. What is the time dilation meaning? That means time is observed in one observer given two references frame s and s dash. One is rest position, another one is moving with respect to some velocity v. When the keep the watches in s and s dash, a s dash observer observe the time in s dash frame is greater than or very later very lengthen time of the yes. This is the uh, time dilation means time increases, it will increases. See here, s dash time dilation change in time in delta t, s dash is given by delta t dash. So by simplification, we are using Lorentz transformation equations for delta t in s frame, delta t dash in s dash frame. By substituting these values, we get delta t dash is equal to delta t by under root of 1 minus v square by c square. Finally, this equation concludes that delta t dash is greater than to delta t. That means what? When we observe the time in a s dash frame, at the same time observed the time in a s frame, there is a difference between. He observed the time more compared to s in s dash. This is the time dilation. So that is the time dilation. It is application of Lorentz consequences. So here we observe this application when the frames, and we consider it two frames s and s dash. One frame is rest, another one is moving with some velocity with respect to that s. That velocity is compared to the light velocity. This type of phenomena occurs. That means length contradiction and time dilation. So we consider these special cases when v is very small to compare to c. C means light velocity. The factor c v square by c square will be negligible. So delta t dash is equal to delta t. That means the time interval recorded by moving clock in a same as that of when it is rest. So that means s is a rest frame. S dash is also same time when slide it frame s dash frame velocity is very negligible and very small compared to the light velocity. When v is compared to the light velocity, it will be less than unity. So delta t dash greater than to delta t. That means when the frame of reference s dash moving with respect to s comparable to the light velocity, when that occurs the time dilation, when the observer observes the time s and it is more in s dash, it is more compared to the in s dash, and that means s is a consider exact time, but in s dash we consider that given more, and whatever the time is observed in s, more than time you observed in s dash frame, that is the time dilation. And at this condition, time dilation is occurs when the s dash frame velocity is comparable to the light velocity, that means c. So light velocity indicated by the c. So when s dash frame velocity is equal to the or greater than light velocity is equal, so delta t dash imaginary, it is impossible. Nobody can get the speed of light in anywhere and but any conditions it is impossible, but the delta t dash is we get imaginary, that is the imaginary case. And nobody can get the light velocities, attain the light velocities only less than or equal, equal also not possible, but we consider only comparable to the velocities. So this is the time dilation concept of simultaneously. Here we see the simultaneously means the two events are happen at the same time. If two events are happen at a same time, that is called simultaneously. That simultaneously is came from the special theory of relativity. What is the time dilation? How much of time we get more from one event to another event? This is given by the mathematical relation delta t dash is equal to 10 to the 10 to 10 to the power minus 10 seconds. This is the time dilation for in case of meson's decay, pi meson's decay. These are the special theory of relativity. These are the special theory of relativity. These concepts, Lorentz transformations, Lorentz transformation equation applications, Michelson-Morley experiment, Galilean experiment, Galilean transformations, Galilean inverse transformations. Where are they applicables? What is special theory of relativity postulations? This type of concepts are we are learned until. So our next chapter is simple harmonic oscillator. These are our fourth unit. Here we are studied the simple harmonic oscillator, damped harmonic oscillators, forced harmonic oscillations. What is resonance? Where the resonant condition, when it is formed resonance. This type of questions we are learned in our next class. Okay.